Hello, today we're going to be colouring in this picture of Earth and the International Space Station and also the Moon. The colours over here on the left are the colours I'm going to be using. I've got two shades of grey here, these are for colouring in the Moon. If you don't have two different colours of grey, don't worry, you can just use a normal pencil and colour some part in really hard and some part in really light. So then you get like the same effect. So let's start with the green. And we can start colouring in the land. I'll make my brush a little bit smaller because this is quite detailed. Well, not detailed, but you know, the UK isn't exactly a square. So if you want to as well, one thing you could do is try and like see if you can figure out where the borders are for countries. So like there's the border for Wales, that's quite an easy one. Scotland's about there. That's Northern Ireland. That's Spain and France. Portugal's about there. And I think Morocco's about there. Now this is a cartoon map, so it's not super accurate. And also I'm not a geographer, so I'll do the best I can. Let's see, the border for France and Germany is like there-ish. And then I think Switzerland's like here. That's Italy. And then this is when I start to really struggle. Germany's around here somewhere. And then I think there's a country here, but I can't remember what it's called. That's Denmark over here. This is Norway. There's some more countries over here somewhere, but I can't remember what they are because I'm an astronomer, not a geographer, and I'm really bad with countries. Anyway, see if you can get more countries than I did. So we've got all of Europe here, which is, as you may or may not know, Europe is a continent. And the thing about continents is most of them sit on what we call tectonic plates. So if you imagine underneath the surface of the Earth, so underneath, you know, your back garden, all the houses and stuff, and the oceans as well, there's these giant big rocky plates. Imagine almost like a giant surfboard made out of rock. And there's a few of these all across the planet. And most of them kind of line up the continents. Like there's one for North America, there's one for Europe, I think Africa's sat on one too, there's one for Asia. They're not exactly with our borders, but they're about right. And basically what happens is these giant lumps of rock basically move around the planet. They move very slowly. They move about a centimetre a year. It's very, very slow. So they move all around the planet. And so like the European one and the North American one are actually moving further apart. So every year we get slightly further away from the US. Now, one thing you might have realised is with these giant plates, if they're all moving around, what happens if they hit each other? Because, you know, there's only so much space. And that's when we get things like earthquakes and volcanoes. So as these things are moving around, again, they're moving really slowly. But what happens is, say you get two that go like head on, they'll go like that, like a head on like crash, like a bus crash or something. And then what happens is they'll push each other up. And then what happens is there'll be like a gap, and any liquid underneath, like in the core of the planet, will then squirt up, and that's how you get a volcano. And then it's also a similar thing for how earthquakes happen. So what happens is, if two plates are going alongside each other, even if they're going in the same direction or opposite directions, if they're scraping against each other, then it causes earthquakes. And sometimes what happens is, so if they're like, if you imagine they're kind of going like alongside each other, what happens is because they're moving so slowly, they can always get caught on each other, and then all of a sudden, after say like 10 years, one can jump, and then you get like a big earthquake. That's what happens in San Francisco. So about every 100 years, they get a really big earthquake where the plates suddenly shift, because San Francisco is on the border of two plates. So, and then the other thing as well about tectonic plates is because they kind of exist. So what happens is, like, when you have ones that are going like up, what will eventually happen is they'll push up and then one will slip and go under. but at the same time as it's going under, at the other end, it might be coming back out from underneath the surface of the Earth, and that's how you get things like new islands and stuff like that. So, and it's also like how things like we get like more minerals and like resources for like planets and stuff like that. For plants to grow. So the tectonic plates actually help keep the planet healthy. I'm going to brush a bit bigger for this bit. So once we've finished this, we've got the oceans to do, and then we do the International Space Station and the moon, and I'll talk in those a bit more detail when we get to those. One thing I did want to mention is, you may or may not have known, but this year Earth actually had 2 moons. It doesn't happen very often, but sometimes it does. What happens is these asteroids that are like flying around in space, sometimes they get caught around Earth in the gravity, and then basically then we have a moon for a bit. So this one wasn't there for very long, and it was very small. It was about the size of a car, so it was quite hard to see. That's why you didn't notice it. You can look out your bedroom window one day and be like, oh my god, there's another moon. It's quite small and it's quite far away. But whereas our moon kind of goes around the Earth in like almost a circle, this one was like very crazy, like going in like all different directions. So it eventually got thrown back off into space. And it's not the first time it's happened either. There was another one about 2006. It's a similar thing, and I think it was about the same size. It wasn't the same object, it wasn't the same rock, but a similar thing happened. Okay, right, we've almost finished Europe. And we've got a little bit, this little island here, at the top of Africa. And we have all the oceans to do. So, on Earth, there's about 7 billion people. There's a lot of us. And there are millions and millions of different life forms and insects and animals and all sorts of things. So, although there's a lot of us, there's a lot of other things too. There we go. Right, I'll switch to a blue and start on the ocean. Let's make my brush big up. Ooh, I'll make life much easier. So the ocean's very deep. There's lots of weird creatures. If you've ever seen the TV program Blue Planet, you can see some of the weird creatures there are. Like there's fish that have lights in them and glow in the dark. Others that use lights for hunting other fish to eat. Whales that are huge. I think the blue whale's the biggest creature, and its heart's like the size of a bus. It's very big. And then they don't eat people. They these like tiny little, like almost microscopic creatures called krill, which are very, very small, so they have to eat a lot of them. The krill or plankton, I never remember. They're similar, but they're not the same thing. I always get confused between them. They're basically they're little tiny animals that, like I say, like you can see them under a microscope. You struggle to see them with your eyes, and they feed off light. Like they don't eat anything, they just eat light. So eat light. They're kind of almost like a plant. But one thing I find really crazy is we've explored more of the moon than we have of the ocean. And you think like how little we know about the moon and like how many people have been to the moon and stuff like that. You think the ocean would be a lot more, but it's not. It's because the ocean's so big and so deep. And there's 7 different oceans, I think. Again, this is when my my knowledge starts to get a bit stretched. If you can name all of the oceans, good for you. Feel free to let me know in the comments what they are, because I can remember. There's the Pacific, the Atlantic, the Indian, Antarctic, maybe? I don't know. Let me know what all the oceans are. You probably know more than I do. And this is why I look at stuff out of space, not on the planet, because I'm not very good at stuff on the planet. Right. Almost finished. So one thing you may wonder is when we launch rockets and stuff into space and satellites, a lot of them are launched in America. And you might wonder why that is. And the reason why that is because to do with gravity. Oh, my pen stopped working. There you go. It's to do with gravity and the energy needed to leave the planet. So it takes a lot of energy to launch a rocket into space. So the closer you can get to the equator, the middle of the planet, as you can, the easier it is. Now, for most of the time, it's been America launching stuff because they're quite a rich country and they can afford to send like all these rockets and stuff up into space. But that is changing. So one of the big things was when America a few years ago, or I say a few years ago, it's like 10 years ago, stopped launching their rocket up to the International Space Station, which is called the Space Shuttle. They stopped launching that, and instead they used the Russian one, which launched from a country called Kyrgyzstan, which is like just off the edge of the map here. And it's where Russia launched from, but it wasn't in Russia, it was in like east of Europe kind of thing. And basically, again, like the further south you can get, the easier it is. So like launching from a rocket from the UK, it would take a lot more effort than say if you launch it from the bottom of Spain. And it's to do with the way the planet moves and gravity. Now the big one that's changing things is China, because China is so big, and there's some islands to the south of China where it's more south than Florida, where the rockets launch from in America. So it means they can start their own rocket program and launch it within their own country. Which, like I say, there aren't many countries that can do it. So yeah, that's why. I think also it's a bit more safe to launch as well from further down. I say further down, closer to the equator. So like you see satellites and stuff launch from countries like the UK, but you never see like manned missions of like people going from the UK. So if say the UK wanted to send an astronaut up, someone like say Tim Peake, what they do is he would go on like a plane or something over to America, and he would fly from there. Well, previously he would fly from Russia because America wasn't launching rockets, but SpaceX has recently started launching rockets this year in 2020, and so now they're launching astronauts from America again. Whereas previously it would have been from Kyrgyzstan, which was controlled by the Russian government, and they paid for all the rockets and stuff. And so the British government were like, oh, here you go, we'll give you a load of money and you can send our astronaut up to space. Right, let's move on to the space station. I'm going to keep my blue because I'm going to colour in these solar panels, and solar panels tend to be like a dark blue. So the thing about SpaceX, it's quite a big thing with their recent launch of their rocket, Dragon. I'm not going to worry about the lines. With the recent launch of Dragon spacecraft, is it can launch, I think it has up to 5 seats. At the moment, NASA's only using a couple of the seats, but it has the capacity, has the space to be able to have like up to 5 or 6 astronauts. I can't remember the exact number off the top of my head. This is quite a big deal. So originally, NASA astronauts to the International Space Station used to go up in called the Space Shuttle, and it was basically like a big spaceship thing. and it had 6 seats, so they could send up 6 astronauts at a time. So it meant they could do lots and lots of things while they were up there and have lots of people up there. And then they kind of ran out of money. It's about 2010, I think. Again, I'm not great with years, but it's around that time. They kind of ran out of money and couldn't afford to keep sending up the rocket. So instead, what they did is the Russians also had a rocket they were sending up called the Soyuz capsule, which, like I've said, it was launching from Kyrgyzstan. The big difference between the Soyuz capsule and the space shuttle is the Soyuz capsule only had 3 seats. So it meant you can only send up 3 astronauts at a time, so therefore like half the people. This made things quite difficult because then, whereas before, like when you sent up the space shuttle, if you had 6 people, you could have, you know, a really good pilot, a really good physicist, a really good biologist who like worked with plants and stuff. What it meant then with the Soyuz is if you could only have 3 people, they had to be really, really well trained. So you had to have someone who was a pilot and a biologist, someone who was a physicist and a chemist. Like, so it meant like to be an astronaut, you'd be really highly trained in like multiple fields. Like these people would have like be doctors in like lots of different areas because they had to be, because they could only send up so many people. Now the thing with SpaceX's new rocket is, again, it's got more seats, so it means they can start sending up more people. So we could see things start to change. Also, I should probably explain, if you don't know, the International Space Station is a big spaceship kind of thing. It's like a big box that's flying around in outer space and orbits around the planet, so it goes around the planet. It's something like, it goes around the planet once every couple of hours. I think it's like every 2 or 3 hours it goes around the planet, so it's moving very fast. And you might have seen videos online and stuff of like people like floating around in space and stuff, and this is where they live. So the reason why it's called the International Space Station is because it wasn't built by any one country. It was built by a lot of different ones. Because they were like, oh, like we need something in space so we can study like the long-term effects of people being in space and stuff. So yeah, a lot of countries pitched in and like donated money to it. America and Russia donated the most money, I think, but like the UK and stuff donated money too. Right, there we go. There's all the solar panels coloured in. Right, I'm going to switch to my dark grey because this is metal. And the thing with the International Space Station as well is it's built in like modules. So like almost like if you built your house room by room. So like you're like, okay, we need a bedroom, so we'll start with the bedroom. And then we need a kitchen, so we'll build on a kitchen room, and then we'll add on a bathroom, and so on and so on. That's kind of how the space station was built. So I know one of the big additions was in like the early 2000s was they added a big robot arm called the Canada arm, and basically it was donated by Canada or built by Canada. And so yeah, you can keep adding more and more rooms on. Now the problem with the International Space Station is it's been up there for a long time. I don't know exactly off the top of my head, but it's been up there for like 10 to 20 years, I think, if not longer. Now the problem with things in space is they take a lot of energy to stay in space. Like I've said, like launching rockets and stuff, like the gravity of the Earth wants to pull it back down. It wants to keep things on Earth. So the International Space Station's flying around up there, but it's slowly getting closer and closer to the Earth. So NASA and all the other countries who've kind of worked on it have a choice to make. Either you let the space station crash into the planet. So what you do is you break it up into pieces and crash it into the ocean. Do like a controlled crash. So, you know, don't just let it fall down to the planet and destroy everyone. But put it in the ocean. Or you spend a lot of money to try and keep it up there. And at the moment, I think this is, as of 2020, I think it's got a couple of years left until they need to decide. So at the moment, it's still safe for like a few more years at least. And then in a few more years, when it gets to the end of that time, I think it's about 2023 or something, they need to like have a look at it. Barack Obama was the last person to kind of do like an analysis and be like, yeah, okay, it's safe. Not him personally, he paid a team for it. He didn't just pop up there and go, hey, this looks good. Pen's not working, there you go. So every few years they kind of have to inspect it and be like, okay, this is okay to keep going, or they might be like, okay, most of it's safe, this room needs redoing, like we need to fix some holes and things like that, because of all the other satellites flying around and bits of rock and stuff, sometimes they get holes in it, so I have to like patch them up and make sure it's okay. Right then, onto the moon. I'm going to stick with my dark bit. So you may have seen, when you look at the moon, there's a dark bit and a light bit. And I'll talk about those now. So let's start on the dark bit. So the moon has dark bits and light bits. Let's push a little bit bigger. These are actually completely different areas of the moon. So the dark bits are what we call oceans, and the light bits are what we call mountains. Well, I say mountains, they are mountains. So the moon used to have oceans, but unlike Earth that had oceans of water, it had oceans of lava. So these darker regions, like almost like burn marks all over the moon. So the oceans tend to be lower down than the mountains, and also flatter. So a lot of the rockets, when they went up, like Neil Armstrong, he landed, I think it was around here. Obviously, this isn't a very accurate map, it's a cartoony map. But if you're looking at a picture of the moon, it's around here somewhere where he landed. Him and Buzz Aldrin landed there. There was a couple of the Apollo missions that took people to the moon. A couple of those landed in mountains, but for the most part they landed in the oceans because it's much, much easier. Okay. Right, that's that bit done. Right, let's switch to the light colour. Right, I'm trying to... So this here, this circle is called Tycho, and it's a giant crater. Again, if you look at the moon at night, you'll see at the bottom, you'll see this big crater, or look at pictures. And it's a really, really big crater, so we think it's like a really big asteroid must have hit it at some point. And the moon's covered in craters, as you've probably seen. But what you may not know is the far side of the moon, what we call the dark side, is covered in a lot more craters. So, unlike the Earth, where the Earth spins around and, you know, part of it faces the sun every day and part of it faces the into space away from the sun, the moon is always facing the same way. So imagine this is the Earth, the moon is always facing the same way as we rotate around through space. And that's why we always see the same side of the moon. Now what this means is the back of the moon is always facing away into space. So if asteroids or anything is coming, I say anything, asteroids or comets are kind of coming towards it, they will always hit the far side of the moon. So that's why the other side of the moon has a lot more craters than this side. But because of the way it works and the moon doesn't rotate and we don't see the other side, then we don't see those craters all the time. There's been like satellites and stuff gone up so we can see pictures of it, but yeah, we don't get to see it with our eyes. Now, this thing where the moon always faces us with the same side, we call it being phase locked, and it's actually quite common when you look at planets in like other solar systems and stuff. You know, like planets going around other stars. You see, it's quite common for planets to be phase locked. And then what this means is, I mean, the moon's quite small, so it is noticeable, but other planets, like when they're bigger, it's much more noticeable, is if you've got one side, so like if it's phase locked to the sun, so the same face is always facing the sun, what that means is the side facing the sun is really hot, and the side facing away from the sun is really cold. So it means for things like plants and animals and any life really to grow, it's quite difficult, because it's either so hot or so cold that it's really hard for life to grow. But there's the edge, so it'd be like the edge of this drawing here. Basically the bit between the side that faces the sun and the side that faces away from the sun in these other planets, would be maybe about the right temperature at like certain points. So those could be points where life could grow. But it's obviously quite hard to study those because these planets are so far away. I'm talking like millions and billions of miles and kilometers away. Alright. I'm trying not to colour in this crater. If you've ever read the book 2001, A Space Odyssey, or seen the movie, a lot of it is based around this crater, or the start of it's based around this crater, because the author of it was a very, very smart scientist who wanted to base it on real things, and so he used this crater Tycho. Right then, let's colour in the heading at the top, I think. I'm going to do it blue and green for Earth, I think. But you can do whatever colour you like. If you want to read another book that's kind of like a fun story, 2001's good, but it's from like the 60s or 70s, so like it's a bit slow and a bit hard to read now. Some people love it, and great, good for you. I tried reading it a few years ago and I found it quite hard to read and found it quite slow. But if you want another book that's quite accurate and a bit more recent, The Martian, which again you may have seen the movie or read the book before, a lot of that, the guy who wrote it, I think it's Andy Weir is his name, he did a lot of research into like how it would be possible like for like people to live on Mars, and like how hard it is to grow potatoes on Mars and stuff like that. He did a lot of work to try and make it as scientifically accurate as possible, but also try and keep it fun. So I definitely recommend that. Okay, I'll switch to green. And it's a fun movie. You get to see Matt Damon try and grow potatoes on Mars. Right, almost done. And then we've got colour in the background, which, as I've learned in the other videos, is the longest bit. But it's fine, because then we get to colour in lots of different stars and stuff. Okay. So, oh, by the way, if you have any questions about like Earth or space in general, feel free to put it in the comments. Switch to black. Feel free to put it in the comments, because I don't think of everything, and I might have quickly gone over something that you want to know in a bit more detail. So feel free just to let me know, and I will do my best to try and answer it. I'm gonna go right to the edges actually. Sometimes I try and stay in the box. I don't feel like staying in the box today. Alright, I'm going to do all these big areas first, and then go round things with the smaller brush. Oh, so I recently learned about a new rover that's being sent to Mars. I might do a colouring sheet like just for this in the future, because it's quite cool. It's a new rover being sent to Mars called Perseverance, and it's being launched by NASA, I think. But the big thing about it is it's going to have a drone with it, which has never been done before. Well, not on Mars anyway. I don't know about other planets, but as far as I know, it hasn't been done. It's really hard to colour in that bit. There we go. So basically what's going to happen is the rover's going to be flying around, and then it's going to have a drone that will fly around. Sorry, the rover will be driving around, and then the drone will fly off. This one's just a test, because like I said, it's the first one. But the idea is, while the rover's driving along, the drone could fly ahead and look for safe paths. And then also, it can look for interesting things. So it might be like, oh, that crater looks kind of interesting. The drone could go have a look, take some pictures, and come back and be like, oh, actually it's not that interesting. Let's try a different one. And then, yeah, also it can fly ahead and be like, okay, this bit's quite rocky and dangerous, with like, say it's like on a cliff or something. We need to find a really careful way to get the rover through it. The drone can fly ahead and then have a look. Now, this drone is just a prototype because, like I say, it is just testing out the idea. So this drone can only fly for, I think it's about 90 seconds, and it can't fly any higher than about 5 meters, which obviously, if you think of like drones you see here, they fly like a mile in the air. The problem is, on Mars, the atmosphere isn't very thick. So like when you think of like all the air and stuff we have here, that's a lot of air. So it's quite easy to like keep a drone up, whereas like on Mars it takes a lot more effort because it doesn't have this like big cushion of air to like sit on. So that's why they have to test this one out first, check to see if it works, and then on future missions they can then take drones with them. So I just think it's quite cool to see like, you know, how technology is really changing really fast. Especially because drones are like quite a recent-ish thing. Like they've only been around for like 5-10 years. Like, well, in the way that we know them. Before that, you get like remote control helicopters and stuff, but they weren't very good. Cool, right, coloured in the title. Let's see if I can colour this bit in without destroying everything that I've already done. So one thing you might wonder is, what do astronauts on the International Space Station do every day? For the most part, they do a lot of science experiments. So they'll study things like how do plants grow in space, and stuff like that. Because, you know, say we want to go to Mars or Jupiter or anything further away, I think it takes about 9 months to get to Mars, and then like the other planets are like even further. So, you know, we might have to try and grow our own food on a spaceship. So they're studying like to see how plants grow in space. And then the other one as well they study a lot is, well, I say a lot, it's the one they found that's best survives in space is this animal called a tardigrade. They're really small, like, again, you need like a microscope to see them, but they are really, really tough. They'll basically grow in like anything. So things like that we found. There's one recently, there was an astronaut called Scott Kelly who, I think he was in there from 2018 to 2019. He was up there for almost a year. Was it just over a year? It was around a year anyway. And he was part of a study group. It was called a twin study. And as the name suggests, he had a twin brother. And basically what they did is NASA was studying the long-term effects on people's bodies when they're in space. So what they did is like they measured this guy Scott Kelly before he went up, and they measured his brother and like saw the differences. And they both went about their lives. So Scott Kelly was up in space doing his science experiments and stuff, and his brother was just doing his normal job. I don't know what he does, but he was doing his job on Earth. And then when Scott Kelly came back down, they could then like measure him again and compare them. And like, because they're brothers, things like their cells were not exactly the same, but more similar than like mine and yours would be, because we're not related at all. So what they could do then is like study him in detail, and like they found things like parts of the cells would change in ways that they hadn't known before. So that's kind of experiments that get carried out. And a lot of these things are for getting ready to go to Mars, because again, like I say, if it takes 9 months to get to Mars, we need to know like what happens to a human body when it's in space for that long. There's a really interesting book. It's more like a documentary book, so it's not the most exciting thing to read, but it is quite interesting, by an astronaut called Chris Hadfield, and he just talks about his life and like going to space and stuff. And one thing he talks about is how when astronauts go up to space, because they're kind of floating around in space, their body gets used to being in space and not having gravity. So things like your bones get softer. But then what that means is when you come back down to Earth, even like sitting in a chair is, or like lying in bed, is really uncomfortable because you've got gravity on you again, and it's just like pulling you down into the bed or the chair or whatever. So for like the first few days, it's really like uncomfortable for them, like to even like sleep and stuff, because their body has got used to not having gravity. So it's only by sending up people for like long periods of time we can start to understand these things, and also like try and find ways to get around them. So like one thing a lot of astronauts do, well, I say a lot, they all have to do it, is they do exercise in space. So, but then again, the problem is, like, you know, you can do weights in space, but the weights aren't that heavy because there's no gravity. So you're there, like, you know, I don't know, 20 tons of weight, and you're like pushing away, being like, oh, this is easy, highest weights ever. But it doesn't matter because you won't feel any weight. So what they'll do is they'll do things like they'll run on treadmills, and they'll do things like they might do weights with like elastic bands, almost like giant elastic bands. So when they're pushing the weights away, the elastic band is like trying to pull it back towards them, so they still get to like work out a bit. And the reason why they do this is to try and keep their muscles. And I'm not talking like big muscles for show. I'm talking about like, you know, the muscles you need for walking and stuff like that, because while they're in space they lose them because there's no gravity. So it's like a really important part of an astronaut's day is working out. And like also like astronauts tend to be in pretty good shape anyway, because they have to be. Because, well, I say because you have to be, like, you might know, but you might not know. Like things like when they go up into space, when they're launching up into space off the Earth, there's so much force coming down from the gravity. It's like pushing them back into their seats. And you might have seen, like, again, like silly videos and stuff, like their faces like all being pushed back and stuff. And what this is, we call it Gforce. And again, like the G-forces are really strong, so like the average person on Earth doesn't experience this very strong G-force. The one time you might feel it is if you're in a car and you drive really fast around, like turn the corner really fast, and you get thrown out to the side. That's the G-force throwing you out. But the G-force is quite weak. Well, it's what we call centripetal force. And the G-force is like, it measures how strong that force is that throws you out. So for the most part, it's pretty weak. But the other ones as well who experience it really strong is Formula 1 drivers, because the cars drive so fast and brake so fast, they experience this G-force. And also fighter pilots. Fighter pilots are the ones who have it like the most. And there's all sorts of things where, like, if a fighter pilot, like, say does like a really fast dive and then turns up at the last second, they've learnt certain ways to do it, because if they do the turn in other ways... Oh, my friend's turn up. Because if they do it in other ways, they'll experience like such a high G-force that they'll lose consciousness and then crash the plane. So they'd be really careful about stuff like that. And so basically, to be able to try and make that easier on someone, the fitter you are, the easier it is to like withstand the G-force and like stuff like that. So there's a lot of things about astronauts, like, you know, how they have to eat healthy, and they have to like not have any illnesses or anything. And the reason why is because they have to go through like such hard things. And sadly, there's been like astronauts who've, you know, spent their whole life training to be astronauts and been like, yeah, one day I'm going to go to space and live my dream. And then they get to like the day, and, you know, or they have a test, and all of a sudden they have a condition that means they can't go to space. Like, say they have heart problems or something. So sadly, it means they can't go to space. Now, it's not the end of the road for them, though. Like, there's a lot of people that work at NASA, and like things like a lot of the advisors, so like the people they're talking to back on Earth while they're up on the space station, or even when they're on the moon and stuff. A lot of the advisors are like very, very important people, because, you know, the decisions they make could choose if these astronauts live or die. So, you know, if your dream is to be an astronaut, great. But also there are a lot of other jobs that are just as important that are also out there too. So you think, like, again, like in any movie, they have like mission control, who's like, they're like, mission control, we have a problem. You know, they need all those people and they need researchers. And you know, there's people who plan out like the flight times for the rockets and like where it's going to go and stuff like that. Like things like when Neil Armstrong went to the moon, they had to have like a team of people that all chose the perfect landing site for them to land on. And you know, they had to look at each of them in detail and do like weeks and weeks of research and like figure out which was the right one. So like I say, like just because they're not astronauts doesn't make them any less important. They're still really important people. Right, we are almost done. Finish coloring this bit and then do all the stars. Oh, so one thing I forgot to say earlier is I talked about how China are kind of launching their own rockets and stuff. I mean, they have been launching satellites and stuff for years, but they're trying to start doing their own manned missions. And there's also rumours that they're going to be doing their own space station. The problem with China is they like to keep their stuff very secret and basically only like talk about it like as it's launching. So you don't know anything for definite until like it's actually happening. But there's been like hints and stuff that they're going to launch their own space station soon. And again, they'll do it the same as like the International Space Station. It's still a microphone. There you go. They'll do the same as like with the International Space Station, where they'll launch it up in bits and do it like room by room. Right, let's add the stars and then we're done. So as always, you just want to put some random circles of like a yellowish colour. Oh, mine are kind of turning into smudges, but it's fine. Oh, we don't want to put one in that. So, top tip, if you're ever drawing the moon, but you're not drawing it as a full moon, is that you're only doing part of the shape. Don't draw stars where it's dark but where the moon would be. So what you want to do is you want to imagine the moon is like a circle, and then even if you draw like a crescent, like say I draw a crescent like over here, and this bit was black, don't draw stars there because the moon's still there just because you can't see it. So top tip for drawing the moon there for you. Right, I think that looks good. I colour in that bit, but I think I'll just leave it. So yeah, thank you for watching. I hope you enjoyed it and learnt some useful stuff, and I'll see you in the next video.